What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at our second index law, which is talking about brackets. We're really looking at what happens if there is a base, brackets, and then a power on the outside. The big thing that we need to remember is that a power is just saying how many times is a base multiplied by itself. So 3 to the power of 4 is just 3 times 3 times 3 times 3, and we're right on top of that. This is the key understanding for this lesson. If you already know that, the next step is not going to be too difficult. So if I've got 3 to the power of 4, brackets all squared, what's that actually saying? The same conceptual idea of the base being multiplied by itself still appears. So if I've got 3 to the power of 4 to the power of 2, that means I've got 3 to the power of 4 times by itself. So 3 to the power of 4 times 3 to the power of 4. Now all I've got to do is use my multiplication skills that I learned in the last lesson. As long as the bases are the same, I can just plus the little numbers. This becomes 3 to the power of 8 full marks. You might have been able to see a little shortcut though, and we're going to focus on that just to reduce the amount of work we actually have to do. Just one more example though, if I've got 2 to the power of 5 all to the power of 3, that's saying the base, 2 to the power of 5, is being multiplied by itself 3 times. So 2 to the power of 5, 2 to the power of 5, 2 to the power of 5, which is just equal to 2 to the power of 15 by adding up those little numbers. The shortcut here is that we multiply the powers. So the power inside the bracket and the power outside the bracket, they get multiplied, but then the base just remains the same. So that means that 5 to the power of 8 all to the power of 4, instead of writing it out heaps and heaps of times, just becomes 5 to the power of 32. Then if we're looking at algebraic terms, a to the power of 6 all to the power of 3 just becomes a to the power of 18. Done. So these are not too difficult. So what can get a little bit difficult is if we've got multiple terms within the same bracket. So this is a bit of an algebraic extension on what we've just learnt. So this one here, a times b all to the power of 2. What that's saying is we've got a times b, a times b. They're multiplied together. But we know with algebra, if I've got a times a, that's a squared, and b times b is b squared. So the answer for this is a squared, b squared. The same thing happens here if I've got 2b all squared. I've got 2 times b times by itself, 2 times b. This ends up with 4b squared. So we can see this is a little bit different. We're used to seeing the base, that 2, remain the same. But in this example, it's a little bit different, and that always is going to happen when we've got multiple terms within the same bracket. So if I've got 4x to the power of 5 all squared, I'm still going to multiply the little powers together, but I actually have to do the 4 squared like normal. So this becomes 16x to the power of 10. The big takeaway here is that we cannot multiply the big number by the power. That's only what we do with the 2 powers. Instead, I want you to treat it like a normal square, like a normal indice. 4 to the power of whatever that number is. One way that some of my students like to remember it is it's 4 to the power of 1. There's an imaginary 1 with that 4. So then I could use that multiplication rule. 4 to the power of 1 times 2, or 4 to the power of 2, x to the power of 5 times 2, which is 10, and that's how I get that answer of 16x to the power of 10. So here I'm going to put all my skills together. So I'm using the brackets that I've learned in this lesson with my dividing skills from the last lesson. The first thing I've got to do is work out this bracket. I've got 2 with a little imaginary 1, y to the power of 5, all to the power of 4. So this becomes 2 to the power of 4, y to the power of 20. Remember, I can't just do 4 times the big 2. That's not going to work. And again, this is still divided all by 4y to the power of 6. But instead of writing 2 to the power of 4, I'm actually going to solve that, and that's equal to 16. So this is what my actual division is going to look like. So here I've got to divide the whole numbers just like normal, and then minus the powers. So 16 divided by 4 is 4, so I've got 4y, and that's 20 minus 6, which is just 14. This is the final answer for this big question, just making sure I'm doing the same steps over and over. Solving the brackets first by multiplying the power and actually doing the power with the whole number, and then dividing that just like normal. Thanks so much for watching this lesson, guys, and I'll see you later.